Hello everyone, in this video we are going to take a look at a problem of using the simplex methods to solve a linear programming problem. For this problem, we are asking to find the x1 bigger than or equal to 0 and x2 is also bigger than or equal to 0 such that we have the two constraints inequalities. X1 plus 2x2 is greater than or equal to 24 and x1 plus x2 is less than or equal to 40. And we want to maximize this objective function z equal 12x1 plus 10x2. Now we learn about two cases. Anytime that the constraint inequality has the notation of less than or equal to something, that would be the maximization problem. Or if the constraint inequality has the notation of bigger than or equal to something, that would be the minimization problem. For the maximization problem, we just simply add a slack variable, and for the mean problem, we subtract the surplus variable because we want to first convert the constraint equation, these two inequalities, back to the equation with the equality notation first before we can do any other calculation. So the first step here, I need to look at the objective function z equal 12x1 plus 10x2. I need to move everything on the left side together with z and leaving the right hand side to be 0. So by subtracting 12x1 on both sides, I have minus 12x1. And then if I subtract 10x2 on both sides, I have minus 10x2. And adding z equal to 0. So this is our objective function. And we want to maximize this objective function. And for the other two constraints inequality, now we have something here is greater than or equal to 24. That is the mean problem. So before, but now we have both of them. So this is the mixed problem or the non-standard problem. So all you do now to make this to have the equal notation is by introducing a surplus variables. So I know that when x1 plus 2x2 and then subtract some s1, right? And that surplus variable here, when you do the subtraction, you will get down to 24 because we are bigger than or equal to 24. So if you subtract something, the surplus variable, to the point that you get to 24. And then for the other case, less than or equal to 40. So x1 plus x2 is already less than or equal to 40. So if you want this to be 40, then you need to add something. So x1 plus x2, and we add to s2 equal to 40. s2 could be 0, right? Or anything bigger than that. So, but we need to add something in order for x1 and x2 to be adding up together, and with that extra or the slack variable to get to 40. And now we need to write the initial Tableau. Okay, so let's write that here. So below we have the initial simplex Tableau. We have the variable x1, x2, and then s1, s2, and also z. So what I have here is x1, x2, s1, s2, and then z. All right, now I'm going to take the coefficients of these variables and then I place them below here. So here we have the coefficient of 1. I have 1. Here we have the coefficient of 2 for x2, negative 1 for s1, nothing for s2, so 0. And then we don't have anything for z, so 0 for z. And we have equal 24 on the right hand side. And then the other constraint equation right here, we have x1, which is 1, x2, which is 1, no s1, so 0, s2, we have 1, and z, we don't have z, and then the right hand side is 40. So we write the two rows for the two equations here, and then we draw another line, and then finally we combine this with the objective function, the one that you are trying to maximize. Minus 12x1. So x1 is here. We have minus 12. And then x2 minus 10. We have here s1. s1 we don't have it. s2 we don't have it. But then z, we do have z to be 1. And then we have 0 for the right hand side. So this is the initial simplex Tableau. Alright, now looking at this one, we can find the initial basic solution. Initial basic solutions. Before we do any calculations, we can find the initial basic solutions. Alright, so what is the solution here? Well, if you look at S1, we see that we have 0 here, 0 here, 0 for the other two rows. So I have -1 here. So I have -1 with S1 give me -S1. And that value of S1 is equal to 24. So this tells me that S1, I can multiply both sides with -1, so S1 is -24. And because this is the surplus variable, okay, this one is the surplus variable. Because right here, you are subtracting it from this constraint inequality to get down to 24. So because of the negative value of the surplus variable, the initial basic solution is not feasible. Okay, it's not feasible. Anytime that we have a negative surplus variable, then the initial basic solution is not feasible. Also, the other solution I see from here, if I look at this row, this column right here, the pivot 1 by itself, and the rest they are 0. So 1 here corresponds to S2. So S2 is equal to 40. So according to the pivot locations, the S2 has the value of 40. And for X1 and X2, we don't have the pivots from this column or this column. So X1 equals 0 and X2 equals 0 because we don't have the pivot 1 for this column and this column. So they are all 0. So these are the solution, the initial solution for this initial simplex tableaus. And of course, it is not feasible because the value of the S1 is negative. And now, the next step is we need to find a pivot. Okay? So by looking at the first two rows, I see that this one has a negative value. So we look for the negative value. From the first two rows, we find the location of the negative value. And then, after we find the negative value, we look for the positive entry that is farthest to the left in that row. The positive entry that is farthest from the left in this row would be 1. So here, we want to make this as the pivot. And now, the goal is to make this guy here to be 0 and this guy here to be 0. But you might ask a question. So after we know the negative location, the indicator here, we select the positive entry that is farthest to the left, and then we focus for that column, which is the first column. So we make this one as a pivot. But how do I know this is a pivot, but not this one here? Well, we use a rule that we take this value all the way on from the right side. 24, we divide by this one. So 24 divided by 1 is 24. And then we take the other one, 40, divide by 1. 40 divided by 1 is 40. We pick the smaller value. We always pick the smaller value. And because this one gives you the smaller value, we take this value as the pivot of this table. And if this one is the pivot, we need to make the rest of that column to be 0. And how do we make the rest of the column to be 0? Well, we can do some row operations. So if I look at this table, I can do something like I multiply -1 to the first row, and then I add to the second row, and then I replace that to the second row. Because the goal here is to make this one to be 0. So if I take minus, I multiply row 1, okay? -1 multiply 1 is -1. And then -1 add to 1 is 0. And 0 now, we are replacing that to row 2. So we are replacing this to the second row, so this will become 0, which is what we want. And then I take -1, I multiply row 2 for this second column, which is -2. -2, I add to row 2. I add row 2. So -2 add 1 is -1. And -1 is the new value. And then I do the next one. -1, I multiply here, which is -1, and -1 give me +1. +1, I add to 0 is +1. And +1 stay here. And then -1 multiply 0 is 0. And 0 plus 1 is 1. And then -1 multiply 0 is 0. And 0 plus 0 is 0. And then -1 multiply 24 is -24. And -24 you add to 40. Right? -24 you add 40. That's going to give me +16. And now I have the 0 for this location. And I need to make the 0 for this one as well. So we can see that I have -12. If I look at the pivot row, I want to make this one to be 12, so that when I add to -12, it makes this thing to be 0. So what I can do here is I have another operation, multiply 12 to the first row, and then add to the third row, and then replace the results to the third row, because I want to get a new row here. So 12 multiplied to the first row, 12 times 1 is 12. 12 plus -12 is 0 down here. And then 12 multiplied by 2 is 24. And 24, I plus -10, that is 14. And then 12 multiply -1 is -12. -12 plus 0 is -12. And then I have -12 here. And then I have -12 times 0 is 0. 0 plus 1, plus 0 is 0, right? And then you have 0 here. And then I have -12 multiply here is 0. 0 plus 1, it is 1. And I have 12. 12 I multiply 24, right? 12 times row 1. 12 multiplied to 24 is 288. And 288 I add to 0 is 288. So now I'm able to change the 1 and -12 to 0 and 0. And then I keep the row with the pivot to be the same thing again. So I have 1, 2, -1, 0, 0, and we still have 24. Okay, and I still have x1 up here, x2, s1, s2, and the z, and then yeah, that's all. And then we check again. It is the optimal solution, right? We check it again. Well, if you look at this problem, I mean this table, the one down here, the new one. Well, now the basic solution is feasible, right? Because x1 is had the 1 here and the rest two other locations are 0. So the 1 here is positive. And then we have S2, the 1 here, right? And then Z, the 1 here. So we do see that the basic solution is now feasible. But the problem is not yet finished because there is a negative indicator. S1, S2 here, S2 now is positive. Z is positive. X1 is positive. But we still have the negative indicator from the last row. We want to make sure the last row has no negative value as well. Because if this one has a negative value, then we continue with the usual way. We decide what is the next pivot. Okay, so looking at this one, I do see that I have two values, right? Either -1 here or 1. And of course, this one right here is the next pivot. Okay, because it's a positive value, and 16 divided by 1 is 16, right? If this one is 1, then 24 divided by 1 is 24. So you pick the smaller value. So this one should be the next pivot. And now the goal, after we identify the location of the next pivot, we want to make this one to be 0, and we want to make this one to be 0. And there are two row operations we need in order to make this number to be 0 and this number to be 0. I will again call this is row 1, row 2, and row 3. So the first operation I need here is I take row 1, I add to row 2, and then I just simply replace that to row 1. Why? Because if row 1 minus 1 add to row 2, which is plus 1, so add them, it will become 0 here, right here, right? And then I'll replace that to row 1. So we replaced the results to row 1. Okay, so I add row 1 and row 2. 0 plus 1 is 1, and then I replace that to row 1, which is the same thing. -1 add to 2 is plus 1. Plus 1 now is a new location, new number in row 1. 1 plus -1 is 0, and then I replace that to row 1. We are replacing that to this row here. And 1 plus 0 is 1. We are replacing that here. 0 plus 0 is 0, and then the value is 0 here. 16 plus 24, it is 40. It is 40 on the right side. So we are done with this row to make it 0. Now we need to do something to the third row. I want to make this one to be 0. Okay, so what I can do is I multiply 12 to the second row, because we take the row with the pivot. We multiply something and we add to the other row to somehow make this guy to be 0. So I can take 12, I multiply to row 2, and then I add to row 3, and I replace the result back to row 3 because I'm doing the change for row 3. So -12 multiply 0 is 0. 0 add 0 is 0. -12 multiply -1 is -12, and add 14, that is plus 2. -12 multiply 1 is plus 12. Plus 12 plus -12 is 0, and that is what we want, for 0 to stay here. Then -12 times 1, sorry, 12 times 1 is 12. 12 plus 0 is 12. And then 12 times 0 is 0 plus 1 is 1. And then 12 times 16, and then add to 288, it is 480. And then I'll keep my the second row with a pivot to be the same thing. So we have 0 minus 1, 1, 1, 0, and then 16. So this one is the final Tableau. Because the entries in the last row, all of them are non-negative. You see that? No more negative in the last row, right? No more negative in the last row. And then the slack variable or the surplus variable, they are not having a negative value. So we are good now. Remember, this is x1, x2, s1, s2, and then z, right? And if you look at this one, you see that right here, the pivot 1 and the rest, they are 0. So this is the value of x1 is 40. So x1 should be 40. And then I see another pivot here, only number 1 by itself and the rest are 0. This is the s2 and s1, and s1 is 16. And then another pivot here, 1, the rest are 0. And that is the value of z, right? Z equal 480. Z equal 480. And because x2, we have x1, s1, z, we look at x2 because I'm looking for the value of x2. That is what the question asked me. Because x2, we don't have the pivot here with no 1 or no 0, so x2 would be 0. So this should be the answer. Okay, so the question asks you find the x1 bigger than or equal to 0, x2 bigger than or equal to 0, and now we are able to tell x1 is 40, x2 is 0, and these are just the extra information. With this value, we are able to maximize the objective function, and the maximum value is 480 in this case. Again, when do I know that I should stop the operation from the table? Well, if you look at the last row, make sure you don't have a negative value, and make sure the S1 or S2, when you write out the solution, they don't have a negative value. And that is when you can stop and get the final tableaus. And this is the solution. And thanks for watching this videos.